Section 6-1, the set of rational numbers. In this section, we're going to learn different ways to represent rational numbers, which we also call fractions. We're also going to learn about equal or equivalent fractions and how to write them in simplest form. And then we're going to practice ordering different rational numbers, deciding which number is larger than the other. And then we'll finally finish off by talking about the denseness property of rational numbers. The need for a new type of number comes from the fact that there are some situations that whole numbers don't solve, and integers don't either. Whole numbers are great for counting items. You want to count how many cats and dogs you have. You want to count how many friends you have. Whole numbers are great for that. Integers helped us find solutions to equations that whole numbers could not help us with. For example, the equation 5 plus some mystery number equals 0. We learned that there are no whole numbers that will make that work. In fact, the only number that does make that work is an integer like -5. But then if we look at an equation like something that says 2 times some mystery number is equal to 1, we see yet again that we don't have a number yet without fractions that would make this work. 2x equals 1 is basically saying that you have 2 of some number added together, and their sum is equal to 1. Well, the only way to make that work would be come up with a part of a number. If 1 is a whole number, then x in this case would have to be some part of that whole. We might already know that the answer is 1/2, and that's probably because we've learned about fractions at some point in our lives. But when we're teaching about fractions in the very beginning, the best thing to do is start with some visual representations. We have a few ways that we can write rational numbers. We can write them as a fraction with numerator on top, denominator on bottom. We can write them as a fraction with numerator on the left, denominator on the right. Tiny little formatting differences. And then I think often we forget that fractions can also be written as division, the numerator divided by the denominator. So we could write it using that division symbol. If we want to use the whole model, parts to the whole, we need to think about 3 things. We need to think about what is the whole that we are trying to consider. For example, I have 3 visual representations of a fraction, 2/3, on the screen. And in each one, we're representing a whole completely differently. On the left, I'm saying 3 circles makes a whole. In the center, I'm saying 3 rectangles make a whole. And on the right, I have a number line that goes from 0 to 1, representing that we're looking at one whole. Now, it's easy to misrepresent rational numbers using multiple circles or rectangles like we have here. The grouping that I've made implies that the 3 circles are part of one set. And again, the grouping with the rectangles shows that these 3 rectangles are attached together to represent one bar that's been divided into pieces. So when we look at the parts to whole model, these visual representations, we're going to start by looking at what constitutes a whole or a complete set. Then after that, we're going to move on to decide how many equal-sized parts has the whole been divided into. With our circles, we have a group of circles that represent a whole, and we have 3 equal-sized circles. So we've divided the whole into 3 equal-sized circles. With the rectangle, we've divided the whole into 3 equal-sized rectangles, and with the number line, we've divided the whole into 3 equal-sized partitions. The last part of using this part to whole model is to think about the number of parts that are selected. And in this case, I've shaded in the parts that I'm selecting. So in the circle rational number, I have 2 parts selected out of the 3 equal-sized parts that makes a whole. Same with the rectangle. I have 2 of the rectangles shaded in, 3 rectangles made a complete set. And then even on the number line, it's the same thing. We have 3 equal-sized parts of our number line. The partition is 3 equal-sized partitions, and I'm drawing a line past 2 of them to represent that I'm selecting 2 of the partitions out of the 3 that we need to make a whole.